Have you seen water or oil spilled on the road on a sunny day from a certain distance as you pass in a car? There is no water there. It's just an illusion. How do you see that? A man on a camel sees the reflected image of a distant tree and thinks that there must be water near the tree. When he gets near, he finds the water is not there, and he's been deceived. How does it happen? During the day, the sand becomes hot, and the layers of air in contact with sand become hot and less dense. The upper layers are comparatively cooler and denser. A ray of light coming from the top of a tree passes from denser to rarer layers successively and gets bent away from the normal. When the angle of incidence becomes greater than the critical angle, the rays are totally internally reflected. The rider views the complete inverted image of the tree as if it were formed by reflection from a water surface. A mirage is an optical illusion due to atmospheric refraction. Atmospheric refraction is the deviation of light from a straight line as it passes through the atmosphere due to the variation in air density as a function of altitude. Have you observed the apparent wavering or flickering of objects seen through a fire? This wavering is an effect of atmospheric refraction. The hotter air is lighter than the cooler air, so the refractive index of hot air is less than that of cool air. Is the air stationary around us? No, air is not stationary. So, when we see any object through hot air, the image of the object fluctuates due to this physical condition. Can you think of some more instances of atmospheric refraction? How do stars twinkle? The light from the stars reaches our Earth after traveling a long distance. The light travels through different layers of the atmosphere. The density of air decreases with increasing altitude. When light from a star travels through different layers of the atmosphere, it bends constantly. The star appears to change its position slightly. Owing to the physical condition of the air, the light from the star varies continuously, and the amount of light entering the eye oscillates. The star appears to flicker, sometimes appears brighter, and sometimes appears fainter or dim. This accounts for the twinkling effect. You know, we are able to see the sunrise 2 minutes before the actual sunrise. You know, we are able to see the sunset 2 minutes after the actual sunset. This is also the effect of atmospheric refraction.
The Hope diamond is valued at about 200 million pounds. Much more. A piece of cut glass of about the same size is worth only a few pence. How can a jeweler tell the difference between a diamond and ordinary glass? Push a shopping trolley onto the grass at an angle from the car park. If the right wheel hits the grass first, since the medium provides more friction, the wheel slows down. But the left wheel is still on the pavement and moving at the same speed before, so the trolley quickly turns to the right as it moves on to the grass. Similarly, a glass slab, when placed in the path of light, changes the direction of that light as it travels from one medium to another. Fix a white sheet of paper on a drawing board. Place a rectangular glass slab in the middle of the sheet. Trace the boundary of the glass slab and name it ABCD. Remove the glass slab. Draw an incident ray IO. Fix 2 pins on the incident ray IO. Draw a normal N1, N2 at the point of incidence O. Place the glass slab exactly on its boundary ABCD. Look from the other side of the glass slab. The 2 pins are clearly visible. Fix 2 more pins exactly in a straight line with the 2 pins that are already there. Now remove the glass slab and all 4 pins. Mark the points P1, P2, P3 and P4. Join P3, P4 to represent the emergent ray O1E. Draw a normal N3, N4 at the point of emergence. Join OO1. OO1 is the refracted ray. Use the protractor to measure the angle of incidence I, angle of refraction R, and the angle of emergence E. The angle of incidence I is found to be greater than the angle of refraction R and equal to the angle of emergence E. Extend O1E backwards and represent it by dotted lines. It is observed that the emergent ray extended is parallel to the incident ray. When light passes from air into glass and back into air, if the refracting surfaces are parallel, then the emerging ray is parallel to the incident ray, just shifted over. This shift is called lateral shift or lateral displacement. When light travels from a rarer medium to a denser medium, it bends towards normal. When light travels from a denser to a rarer medium, it bends away from the normal. Do you know? Owing to refraction, birds see fishes in a different position than they are actually occupying. Even so, birds catch them easily. They overcome the visual effect of refraction out of practice. A prism is made of transparent material, usually a piece of glass, bounded by 2 triangular surfaces and 3 rectangular surfaces. One of the rectangular surfaces is the base of the prism, and the other 2 surfaces are the refracting surfaces. The line joining the 2 refracting surfaces is called the refracting edge of the prism. The angle between the 2 refracting surfaces is called the angle of the prism. Any section perpendicular to the refracting edge is called the principal section of the prism. When a beam of white light is made to fall on a glass prism, the prism refracts the light and splits into 7 different colors. This was first observed by Sir Isaac Newton. Now, let's trace the path of light through a prism. Place the triangular surface of the prism on a white sheet of paper fixed on a drawing board and trace its boundary as ABC. Remove the prism. Fix 2 pins T and S on one side. Place the prism on the boundary ABC. Look through the other side of the prism and place two pins, Q and R, in such a way that all the four pins are in the same line. Remove the pins. Join TS and QR and extend them to meet the faces of the prism at P and O respectively. Join PO. TP represents the incident ray, PO represents the refracted ray, and OR represents the emergent ray that bends towards the base. Draw normals PN and ON at points P and O respectively. Mark I as the angle of incidence and R as the angle of refraction. The incident ray is extended forward and the emergent ray is extended backwards. They meet at M, forming the angle OML. Measure the angle. This angle is called the angle of deviation.